Hi, this is Arjan. In this video I'm going to explain the code of the TickTick game. As you can see, I've opened the code here in my development environment, so let's go through some of the classes. So there are a number of folders in the project. One folder is the game management folder. So this folder actually contains all of the basic classes that are used for the game. And these classes are examples of classes that you can basically use in any game. For example, there is a very generic game environment class that you can see here that basically covers the entire part that you have to write in monogame. So there is a graphics device manager, there is a sprite batch, we have some variables that are needed for varying resolution and aspect ratios, we have a random number generator, basically everything that you're going to need if you want to create your own game. You can also see here there are some useful methods like apply resolution settings that applies either full screen or windowed game resolution settings, and it calculates the correct viewport dimensions in order to satisfy those resolution criteria. And the other thing that this class does is that it calls the correct game loop methods such as handle input, update, and draw. And as you can see in the handle input method, it automatically updates the input helper object that is responsible for dealing with all the aspects of input handling. So how do we use this class? As you can see, we have a TickTick class that is basically a subclass of game environment, and inside we can set some specific properties such as the location of the content and whether the mouse is visible. And then in the load content method we perform our game specific things. There are a few other classes that are interesting in this game management folder. One of them is the game object class, which forms the core of all the objects in the game. It's abstract. That means that it's not allowed to make an instance of this class, but you can inherit from it. And the class that inherits from it, of course, you can make an instance of that class. So what is a game object? Well, it has a parent, so this allows you to create hierarchies of game objects. A game object has a position and a velocity. It has a layer, which indicates where it should be drawn. It has an ID, so you can find it. And it has a Boolean variable that indicates whether it's visible. And finally, it has the game loop methods. So the game object class basically doesn't handle any input unless you override this method. The update method updates its position according to the velocity value. And finally, the draw method. As you can see, the draw method is also empty because a game object doesn't have anything to draw yet. There is, however, a sprite game object, which is again a subclass of a game object, but that one has a sprite. And the sprite can be drawn on the screen. So this class basically implements the draw method and calls the draw method of the sprite batch. There is also a text game object, which doesn't draw a sprite on the screen, but it draws text on the screen of a given font. Then one more game object I'd like to show you is the animated game object. Animated game object is a subclass of sprite game object. But what it allows you to do is to define different animations, and you can select a different animation wherever you want by calling the play animation method. And play animation method switches out the current sprite by the sprite that's stored in the animation. And an animation is actually a sprite sheet, but the difference between an animation and a sprite sheet is that depending on the time, it selects a different frame to be shown. Before I talked about game object and game object having a parent, and that this allows you to create a hierarchy. So by creating these parent relations, you can get parent-child relationship in your game object. So you could, for example, have a car that has wheels, and the wheel might have screws or other parts. And there are a few classes that can help you achieve this. So one of them is game object grid, which allows you to create a grid of game objects. As you can see, game object grid itself inherits from game object, so you could if you wanted to make grids of grids and make all kind of very complicated structures if you like. Another important class is GameObjectList. GameObjectList is also a game object. So you can make lists of lists, and this allows you to create a hierarchy. So GameObjectList basically has a number of children, and you can add these children to the list by using the add method. You can remove them, and using the ID system, you can find these game objects. Furthermore, the list makes sure that the game loop methods such as handle, input, and update are called on the children. If you go back to the TickTick class, you see that basically the load content method doesn't seem to do very much. It adds basically a number of game states to the game state manager. And when it has done that, it tells the game state manager to switch to the title menu. Each of these game states is responsible for a whole part of the game world. And depending on the type of the game state, it can be a very simple one or it can be a very complicated one. Let's take a look at some examples. So the title menu state is a game object list and is an example of a game state that's quite simple. It has basically only a few things. It has a background, which is the title screen, and it has a play and a help button. And in the handle input method, it simply checks if one of these two buttons was pressed, and if so, it switches to another game state. So let's see how that works. So here you see what the title state looks like. So it has a background and it has these two buttons. So I can press one of these buttons and then I switch to another game state, like help. The help state also has a background and again a button, and the back button in the help state switches back to the title state. And when I press play game, I go to the level selection menu. The game state manager is responsible for switching between all these different game states. It allows you to add game states. It allows you to switch to a different game state. And what this class does is that it maintains what the current game state is in a member variable called current game state. And the only thing it does is to make sure that the game loop methods, handle input, update, draw, and reset are called on the current game state. Another thing I'd like to show you is the level loading mechanism. If you look at the content in the project, you see there is a folder called levels, and this contains a number of text files. Here you see an example of such a text file. So this is exactly an example of what it means to have a tile-based game world. Tiles are very commonly used in games to easily represent levels, and this way you can edit a level in a text file and then you load it when you start the game. And this loading is done in the level class. The level class is a bit special because if you open the file, you see that there is the word partial written in front of it. This is because level is actually quite a big class because it has all the code for creating the level, it has code for loading the level, and it has also lots of code for the actual game loop. So that's why we split this class into 3 files. And partial basically allows you to define a class definition over different files. Because there is partial written in front of the level class, the compiler knows that there are other files where this class is also defined. And in each file where you define a part of the class, you simply write the word partial in front of the class definition. So we have a level game loop, which contains the game loop methods. We have a overall level.cs file, which contains the creation part of the level. So what this does, it loads some backgrounds, it creates clouds, it adds a timer, it adds a few buttons, and so on. And finally, we have a level loading class, and this uses file.io to load the tiles from the files in the levels folder in the content directory. As you can see, we use the switch in order to determine which kind of tile we're going to load. So depending on the value of the character that we're reading, we're doing something else. One example is that we can load a flame tile, which is a particular kind of enemy. So what happens there is that we create this enemy depending on the type of the enemy, we give it some position, and we add it to a list of enemies. And each type of tile that we're loading will have a different method that does something slightly different. one thing I'd like to show you is an example of a few different game objects in this game. So the game objects are created by reading the tiles from the level definitions. And these game objects are defined specifically for the TickTick game. So let's take a look at one. One example, a very simple game object, is the water drop, which is a sprite, but it's a sprite that's bouncing to give it a nice interactive effect. And we get the bounce behavior by performing some calculation with the time. So depending on the X position and the time that has passed, we calculate a t value and we put that in a sine function. Finally, we model the interaction between the water drop and the player. So we look up the player in the game world and we check, is the player colliding with the water drop, and is the water drop visible? If so, we set it to invisible and we play a sound. So here you can also see the output of the tile-based level reading. So the tiles have all been created and I can now control this character. And whenever I collide with one of these water drops, a sound is played and I get points. The player class is also quite complicated, and that's why it's also partial. Part of the player class is dealing with all the input. So you can jump, you can walk left and right. In some cases the player is walking on ice, and that means that the player has to display different behavior. Also, depending on whether the player is still alive, the update method needs to do something else. And depending on whether the player jumped, the update method needs to play a different animation. Furthermore, the player has a few other methods that change the state of the player. So there's explode, which happens if the timer reaches 0. There's die, which happens if the player falls down or is killed by an enemy. And there are a few other useful properties and methods. For example, this one checks whether the player is still alive, and this one checks whether the level has been finished or not. The more complicated part of player behavior is dealt with in player physics. Player physics deals with the interaction of the player with the game world. And the main physics handling is done in the method handle collisions. I will not go into a lot of detail of what this method does exactly, but the gist of it is that it looks around the position of the player for the various tiles that are there. That's happening in these nested for loops. And then it's checking in what sense the player is colliding with some of these tiles. And depending on that, it's fixing the player position to not collide anymore. Finally, the TickTick game has a number of enemies. The patrolling enemy is one of the most commonly occurring enemies in platform games. And this patrolling enemy walks from left to right and then turns around. It also waits for a bit at the edges, and the time that it's waiting is stored in this member variable. Initially, when you create a patrolling enemy, it's not waiting, and it will have a positive X velocity. So it means this enemy is walking to the right, and it's playing a walking animation. In the update method, depending on where it's located, it's checking whether it should stop walking and wait and turn around. Also, an enemy checks for player collision. And if there is such a collision, the player dies. Then there are other enemies that build on this patrolling enemy behavior. For example, there is an unpredictable enemy, which is a subclass of patrolling enemy. But depending on some random value, it turns around. There is also a player following enemy that tries to find out where the player is by calculating the direction in which the enemy should walk. And then if that direction is not currently in the direction that the enemy is moving, then the enemy turns around and starts following the player. By having these different behaviors, you can evoke different strategies from the players in the game. Then we have a couple of other enemies. There is a rocket, which is flying through the screen. There is a turtle, which sometimes sneezes. Each of these enemies have different behavior that the player has to take into account. Finally, you see in the game objects folder there are a few other TickTick specific game object classes, such as a timer or clouds, which are moving sprites in the background. So this concludes the TickTick video. Thanks for watching.